Hello everybody and welcome back to the channel. And today I'll be talking about that how can we calculate the area of any regular polygon, right? So what I mean to say by a regular polygon is that the polygon should all sides of the polygon they should be equal, right? So I'm drawing a polygon, it's a hexagon, and so all the sides of this hexagon they are equal, and we can calculate by a universal formula. Maybe the figure has 5 sides, 6 sides, 7 sides, like what, like 3, which is the triangle, which is the smallest polygon, to infinitely number of sides. You can calculate the area. Okay, so now what I'll be doing is that I will give you the formula and plus its derivation, right? So first we'll start from a hexagon, which because it's pretty simple to understand. Like here I'm drawing a hexagon with all its sides. Basically I've drawn the diagonals here, and this is a hexagon, right? Now what I have derived that every regular shaped polygon can be divided into isosceles triangles. And how many isosceles triangles? It would be the number of sides this figure has. That number of isosceles triangles the figure can be divided. For example, if we take a hexagon, there are 6 sides. So there are 6 isosceles triangles which you can see here. Okay, now what I have done is that I have also derived that an isosceles triangle can also be divided into 2 right angle triangles, right? So I'm dividing this. Now this side will be 90 degrees, and this will be having an angle which we can determine. How? This dot, like around a point there are 360 degrees, right? And these 360 degrees are divided into, there are 6 isosceles triangles, so it would be 360 divided by 6. Now one isosceles triangle is getting divided into 2 right angle triangles, so it will be somewhat like this. And what we can get to know that this, and so the measure of one angle here is 30 degrees, right? Now we got to know the measure of this angle and what we can get from this thing. And if we apply the cot theta is the ratio, like cot theta is actually the base upon the perpendicular, right? So now what I have actually done in my formula is that I have basically applied all of them. Like first we will take out the area of this right angle triangle and then multiply it, right? So first we have to take out the area of one right angle triangle into 2n. Why 2n? Because we can imply here that if in a regular sized polygon, if we divide the figure into right angle triangles, it will be equal to 2 into the number of sides the figure has. Okay, so for example, if you divide this, if you divide this, if you divide this, and similarly these, so you can imply that 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so we know that the number of right angle triangle a regular polygon has is 2n, so we'll multiply it, right? So now we have got the basic structure of what we have to do. That first we have to take out the measure, the area of this triangle right here, which is the right angle one, and then we have to multiply it into 2n, right? So how we will take it out? We know that the formula is for the area of a right angle triangle, it is half into base into height, which is just the simple formula. So what is the base, right? First let me draw this triangle right in front of you. Okay, here it is, and this side is 30 in the case of a hexagon, and this side is 90 degrees. So if we apply the cot theta, okay, so first we will discuss. Okay, we don't know the base here, right? So this is the base, which is unknown, and we know the height, which is the perpendicular. Okay, we know this because it has to be provided, right? This side is known, so let us imply that this hexagon has this side as 2, right? So if we divide 2 into 2 parts, the answer would be 1, right? Now we actually, if we apply this thing, the cot theta, it would be b upon p. We know the p. If we multiply it by p square, the answer will be pb, or you can say it as bp, which is actually the base into the height, right? We explain it, make it very simple for you. We don't know the base, we just know the height. If it is a right angle triangle, we can take out the base from the height by doing this. Cot theta is base upon perpendicular, right? If we multiply it into by p square, which is the perpendicular, you know that p square will be actually p into p. So p and p got cancelled out and we got this bp. So we'll write it here as half into the perpendicular, which is actually the size of the perpendicular is actually 1. Okay, so we know that this, what we actually have to do, so we have to write cot theta into your p square. And what is the p square? The p square is actually side divided by 2, because we know the base of the isosceles triangle, and isosceles triangle can be divided into 2 right angles, so it would be divided. So cot theta into side into 2 squared, right? Why squared? Because we have to make the b upon p bp, right? So now we have got the simple formula with us. We'll write half into cot theta. Now the question would arise that what would be theta? Okay, so what would be the theta here is that we have to divide the 360. Actually the theta here is this angle, which would be actually 360 upon the sides, which are n into 2, right? And if we divide it here, so the theta would be 180 divided by n, right? So now 180 divided by n into the p square. So our p is side divided by 2 squared, right? So this half and this half, they are getting cancelled here. So what our final formula is, it is cot 180 divided by n into side divided by 2 whole squared into n. And using this formula you can take out the area of any polygon by just knowing of precisely any regular polygon by just knowing the side and the number of sides the polygon has. If you like the formula, if you like this video, please hit like, please share, comment and please subscribe to my channel. Thank you.